Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is particular integral. This is a topic from first unit, linear differential equation with constant coefficients. The particular integral means the remaining half solution for LD, linear differential equation with constant coefficients. In first lecture, I discussed the first half solution, complementary function. Let us discuss a particular integral. Now, the reduced form of LD is phi of d into y is equal to f of x. This is the reduced form of LD. Now, to find the pi, the formula is y suffix p for particular integral is equal to 1 upon phi of d into f of x. Now, this formula is from the reduced form of LD. We transfer this phi of d in RHS. We have the formula for pi. It is equal to 1 upon phi of d into f of x. That is, pi depends on the function f of x. Now, there are three methods to find pi. The first one is general method. Second method is shortcut method. Third method is method of variation of parameters. That is VP method. Now, the rules for general method. That first rule is 1 up pi is equal to 1 upon d into f of x. 1 upon d means you just integrate the function f of x with respect to x. Second is pi is equal to 1 upon d minus a into f of x. And it is the formula is it is equal to e to the power ax into integration e to the power minus ax f of x dx. The third formula is pi is equal to 1 upon d plus a into f of x. It is equal to e to the power minus ax into integration e to the power ax f of x dx. Now, the example. Find the pi for 1 upon d plus 2 into x. Here function is x, linear function is here, and the factor is d plus 2, means d is equal to minus 2. So use the third formula here, and the formula is here e to the power minus 2x into integration e to the power 2x into x dx. Now, how to solve this integration e to the power 2x into x? To solve this integration, use u into v rule. Now, what is u into v rule? General formula is here. Integration u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on, where suffixes denote integrations and dashes denote the derivatives. So use here that uv rule. This e to the power minus 2x as it is. Now, what is u and what is v here? Choose u the function whose derivative vanished earlier as compared to the other function. Now, here derivative of x vanishes earlier as compared to the derivative of e to the power 2x. So choose x as u and choose e to the power 2x as v, and use this formula u v dx. U into v1, this e to the power minus 2x as it is. U into v1, u is here x, so write x as it is. v1 integration of e to the power 2x, integration of e to the power 2x is e to the power 2x upon 2 minus second term is u dash v2. Now, u dash means derivative of u. Now, u is here x, derivative of x is 1, so you write here 1. Then v2 means integration of v1. v1 is here e to the power 2x by 2. Its integration is e to the power 2x upon 2. And already 2 is there, so 2 to the 4. And so if we simplify it, we have the pi e to the power minus 2x in bracket x into e to the power 2x by 2 minus to the power 2x by 4. This is the answer. Now, the second example of general method. Solve d square plus 3d plus 2 into y is equal to e to the power x. Now, this is the reduced form of LD. This means it is in the form of phi of d into y is equal to f of x. So phi of d is d square plus 3d plus 2. Equate it equal to 0, which is an auxiliary equation. Now, it is a quadratic equation, so it has two factors. The factors are d is equal to -2 -1. So this there are two factors, -2 -1. These are the real numbers and they are distinct. Distinct means different. So complementary function is c1 e to the power -2x plus c2 e to the power -x. Now the pi for the function here, function is e to the power x. Now the formula for pi is 1/5 of d into f of x. So your phi of d is here d square plus 3d plus 2. So right here d square plus 3d plus 2 into f of x. F of x is the function e to the power x. Now the factors of d square plus 3d plus 2 are d plus 2 and d plus 1, because 2 plus 1 is equal to 3 and the multiplication of 2 and 1 is 2. So the factors d plus 2, d plus 1 into e to the power x. Now there are two factors in denominator. So we will solve one by one. First we will solve for 1 upon d plus 1 and then we will solve for 1 upon d plus 2. So 1 upon d plus 2 as it is. Now solve for 1 upon d plus 1. Now the function is e to the power x. So use the third formula of general method. It is this first term as it is, e to the power minus x. Inside the integral, e to the power x to f of x. F of x is e to the power x into dx. Now how to solve this integration? To solve this integration, use the substitution e raised to x is equal to t. And the substitution is e raised to x is equal to t. So the differentiation is e raised to x dx is equal to dt. So e raised to x into dx is equal to dt. And e raised to x substitution is t. So e raised to t into dt. Now e raised to minus x as it is. Integration of e raised to t is e raised to t. E raised to minus x as it is. Now replace this t by e raised to x. So it is e raised to minus x into e raised to x. Now it is 1 upon d plus. Now solve for 1 upon d plus 2. Now the new function is here e raised to minus x into e to the power e raised to x. This is your new function now after solving for d plus 1. Now solve for d plus 2. Again use the third formula of general method, e raised to minus 2x into inside the integral e to the power 2x, and your f of x is this function now e raised to minus x into e to the power x. Now the base is same, so addition of indices is here. 2x minus x is x. So the term is e to the power minus 2x into integration e to the power x into e to the power x dx. Now how to solve this integration? Put again e raised to x is equal to t and e raised to x dx is equal to dt. And so the next step is e to the power minus 2x into integration e raised to x dx is dt, and this e raised to x is t, so integration e raised to t dt. Now the integration of e raised to t is e raised to t, and the value of t is e raised to x, so put here t is equal to e raised to x. So pi is e to the power minus 2x into e to the power x. Now the general solution, y is equal to cf plus pi. So it is equal to, now the cf is here. And this is the cf complementary function, c1 e to the power minus 2x plus c2 e to the power minus x. So right there cf, and then particular integral is e to the power minus 2x into e to the power x. So this is the general solution for the given LDE, and this is the first general method. Here the general method is over. Thank you.